Okay, let's dive in. We're looking at 2025 today.
Right. And the source we're digging into is, well, it's quite alarming.
Yeah, excerpts from a YouTube video, Acharya Prashant. He calls 2025 potentially decisive, maybe even the most dangerous year in human history.
That's a heavy statement.
It really is. And here on the deep dive, our job is to take sources like this, sift through them, pull out the core insights for you.
Acting as your guides, basically, helping you understand this complex stuff faster.
Exactly. So our mission here, why does the speaker in this source see 2025 with such extreme concern? What's behind it?
Well, the first thing that jumps out is his worry about honesty. He feels leaders aren't really telling people how close we might be to what he calls prelay.
Prelay, like a cataclysm.
Yeah, a major disaster, a cataclysm.
Yeah.
He thinks we're near it, and no one's saying so openly.
And he looks back at the last decade.
He does. He characterizes the period from 2015 to 2025 as marked by, and this is his phrase, extreme dishonesty and hypocrisy.
Wow. So if that's the backdrop.
Exactly. His question is, if we've had 10 years of that, how can we realistically expect positive change between now, 2025, and say 2030?
That's a fair question. It sets a pretty grim stage.
It really does. And he even brings up this really sobering idea that maybe humans will be the first species to actually cause their own extinction.
Yeah. Okay. So a lot of this seems tied back to 2015. You mentioned that year, the Paris Agreement comes up.
Right. The Paris Agreement is central to his argument.
Can you give us the basics on that? What was agreed?
Sure. So Paris, 2015, that was called P15, the UN Climate Conference. Big one.
UNFCCC, right.
Yeah, United Nations Framework Convention on Climate Change. And the big outcome was this legally binding agreement, the main goals everyone talks about.
The emission targets.
Exactly. A 45% cut in global carbon emissions by 2030 compared to earlier levels. And then hitting net zero emissions by 2050.
Okay, 45% by 2030, net zero by 2050. Why those numbers?
They were based on the science available then, aiming to keep global warming well below 2 degrees Celsius above pre-industrial levels.
Pre-industrial, like before we started burning all this coal and oil.
Right. And there was an even stronger goal to try and limit the warming to just 1.5 degrees. That was seen as much safer.
And loads of countries signed up.
Pretty much everyone. 195 countries agreed to these overall goals. It felt like a major breakthrough at the time.
Okay, so global goals. But then you hear about NDCs, nationally determined contributions. What are those?
So think of the Paris Agreement as the overall rule book, the big target. The NDCs are like each country's individual plan.
Their homework assignment, almost.
Kind of, yeah. Each country submitted its own specific target for cutting emissions. And these varied a lot,
Based on their situation, like developing versus developed country.
Exactly. Richer countries, who'd have polluted more historically, were also expected to chip in with money and tech to help poorer countries cut their emissions.
Makes sense. And there's a timeline for these NDCs.
Yeah, there's a review mechanism. Countries are supposed to update and strengthen their NDCs every 5 years. 2020 was the first deadline for updates.
And 2025 is the next big one.
Right. 2025 is when countries need to submit their new targets for the period after that, up to 2030 or even 2035. It's a critical moment to ramp up ambition.
Okay, so we have the big goals from 2015, individual plans, and these update points. But the speaker, he clearly sees a huge disconnect.
Oh, absolutely. That's the core of his concern. It's the gap between those Paris goals and what's actually happening on the ground.
What's the main issue he highlights?
Well, primarily, it's the lack of progress towards that 45% reduction by 2030. Remember, Paris was 2015? We're deep into that decade now.
10 years have passed, basically.
Right. And the statistic he points to is just stark. He says, even if every country perfectly achieves its current NDCs, the ones they've already promised,
Yeah.
global emissions will only decrease by about 2.6%.
Wait, 2.6% compared to the 45% needed?
Exactly. It's a massive, massive shortfall. And it gets worse.
How so?
He also points out that, according to his reading of the data, many countries aren't even on track to meet their own self-declared targets. He mentions India as an example, where he sees targets not being met.
So even the weaker promises aren't being kept.
In many cases, that seems to be the situation. But maybe the most crucial, most alarming fact he brings up
Go on.
is that we're not even reducing emissions overall. Global carbon emissions are still increasing year after year. We're heading in the wrong direction entirely.
Increasing, not decreasing at all. That really puts the 2.6% figure in perspective. No wonder he's concerned about 2025 being decisive.
Precisely. The trajectory is just completely off.
And this ties into something else he mentions, the breaching of the 1.5 degree threshold. Why is that 1.5 number so important?
That 1.5-degree limit, scientists see it as a critical guardrail.
Mm.
Going beyond that significantly raises the risk of triggering really dangerous, irreversible climate tipping points.
Tipping points, like things we can't walk back from.
Exactly. Things that could fundamentally threaten a livable planet, as the phrase goes.
Yeah.
It makes these dangerous feedback loops much more likely.
And the source says we've already crossed it.
The source states that in 2024, the global average temperature actually reached 1.54 degrees above pre-industrial levels. So yes, we temporarily crossed that threshold.
Temporarily, so it's not official yet.
Right. As the speaker acknowledges, climate science looks at long-term trends, usually averages over decades, to officially declare a threshold permanently breached. 1 year doesn't make a trend, officially speaking.
Okay.
But the fact we hit it, even for a year, is a massive warning sign. It strongly suggests those 2030 and 2050 targets from Paris were maybe always unrealistic given the lack of real
The
action.
buffer zone is gone.
Essentially, yes. The margin for error has vanished.
And this brings us to these feedback cycles you mentioned. The potential point of no return. What are these exactly?
Okay, so feedback cycles. Think of them like chain reactions in the climate system. Warming causes an effect, which then causes more warming, which reinforces the effect, and so on.
A vicious circle.
A vicious circle, exactly.
Yeah.
And the big worry is that somewhere between 1.5 and 2 degrees of warming, several really critical, large-scale feedback cycles could get properly activated.
Activated meaning they just keep going on their own.
Potentially, yes. They become self-sustaining. They keep driving temperatures up, even if, hypothetically, humans stopped all emissions overnight. They take over.
That sounds terrifying. Is it certain they kick in at a specific temperature?
Well, meteorology and climate science aren't perfectly exact, right? So the precise trigger points can vary a bit. But the scientific consensus is that this 1.5 to 2 degree window is the danger zone where multiple cycles are likely to start interacting and reinforcing each other.
Okay. The speaker and the source details some specific ones. Let's start with the Ice-Albedo feedback. What's that?
Right, Ice-Albedo. Albedo just means reflectivity. White ice and snow are really reflective. They bounce sunlight back into space, which keeps things cooler.
Like wearing a white shirt on a sunny day.
Exactly like that. But as the planet warms, ice melts. Think Arctic sea ice, glaciers, Greenland.
And what's underneath the ice?
Darker surfaces.
Like-
Dark ocean water, rock, soil, sediment. And dark surfaces absorb sunlight. They don't reflect it. They soak up the heat.
So less ice means more heat absorption.
Which means more warming, which means more ice melts, which exposes more dark surfaces.
The cycle.
The cycle. It feeds itself, and once it gets properly established, it's incredibly hard to stop. The speaker suggests this alone could push temperatures up significantly higher. He throws out numbers like 6, 7, 8 degrees eventually.
8 degrees? What would that even mean?
Unpredictable, devastating consequences. Our entire civilization, our agriculture, it's all built for the stable climate we used to have. A rise like that changes everything. So the key insight. Melting ice flips a cooling reflector into a warming absorber.
Okay, that's one. What about permafrost thaw? You mentioned that too. What is permafrost?
Permafrost is ground that's been frozen solid for at least 2 years straight. Huge areas in Siberia, Alaska, Canada, the Arctic.
Just frozen dirt.
Frozen dirt, rock, but crucially, tons and tons of frozen organic material. Dead plants, animals trapped for millennia. And this stuff is full of carbon.
How much carbon?
Estimates vary, but roughly twice the amount of carbon currently in the entire Earth's atmosphere.
Twice. Wow.
Yeah. So, as the Arctic warms much faster than the rest of the planet, this permafrost starts to thaw, to melt.
And the organic stuff decomposes.
Right. Microbes wake up and start eating it. If there's oxygen available, like in drier thawed ground, they release carbon dioxide, CO2.
Okay, more CO2.
But in many areas, the thawed ground becomes waterlogged, swampy, no oxygen. And when microbes decompose stuff without oxygen,
They produce methane.
Yeah.
CH4.
Exactly. And methane is a super potent greenhouse gas. Over 20 years, it traps something like 85 times more heat than CO2 does.
85 times?
Yeah. So thawing permafrost releases CO2 and this incredibly powerful methane. This warms the planet more, which thaws more permafrost, which releases more gases. Yeah. Another vicious cycle.
A runaway effect.
That's the fear. The speaker calls it a potential carbon bomb. It could overwhelm any cuts we make to our own emissions. It's a huge potential accelerator. Key takeaway. The Arctic freezer is defrosting, potentially releasing a carbon bomb of CO2 and potent methane.
And he linked this to drying peatlands. What's the story there?
Peatlands are similar in a way. They're waterlogged wetland areas where dead plant matter builds up over centuries because the water stops it decomposing fully, like soggy sponges full of carbon.
How much carbon are we talking about?
Globally, peatlands store more carbon dioxide equivalent than all the world's forests combined.
More than forests. That's incredible.
It is. And just like permafrost, they rely on being wet to keep that carbon locked up. But as temperatures rise, they're starting to dry out.
And human activity plays a role too.
Definitely. Draining peatlands for farming, building, or digging up peat for fuel or gardening makes it much worse.
So when they dry out,
The stored carbon gets exposed to air, decomposes, and releases CO2 and methane. Again, warming leads to drying, which leads to releases, which leads to more warming.
and the scale of these releases.
The speaker makes the point that the potential emissions from both thawing permafrost and drying peatlands could actually exceed all the greenhouse gases humans have put into the atmosphere since the Industrial Revolution began.
Exceed everything we've done.
Potentially, yeah. Just to give you context, we've pushed atmospheric CO2 from about 280 parts per million up to around 430 ppm now. These natural systems hold the potential to blow past that. The insight. These vast carbon-rich wetlands are drying and releasing their stores, adding fuel to the fire.
Yeah. Okay. Let's move to the oceans. He mentioned several feedback loops there. First one was increased water vapor.
Right, this one's fairly straightforward physics. Warmer air can hold more moisture, warmer oceans evaporate more water.
And oceans cover most of the planet.
About 70% of the surface, yeah. So warmer planet means more water evaporates, mostly from the oceans.
Okay, more water vapor in the air. So what?
Well, water vapor itself is a greenhouse gas. It traps heat. So more warming leads to more water vapor, which leads to more heat being trapped, which leads to more warming. Another positive feedback.
Amplifying the initial warming. Got it. What about the ocean's ability to absorb CO2?
So the oceans have actually absorbed a huge amount of the CO2 we've emitted, which has slowed down climate change significantly so far. They've done us a huge favor.
But that's changing.
Yes. The chemistry works like this. Colder water can dissolve and hold more CO2 than warmer water. Think of a cold soda versus a warm one. The cold one stays fizzy longer.
Right, the gas stays dissolved.
Exactly. So as the oceans get warmer, their capacity to absorb more CO2 from the atmosphere decreases. They become less effective as a carbon sink.
Meaning more of our CO2 emissions stay in the air.
Right. Which accelerates warming, which further warms the oceans, reducing their CO2 uptake capacity even more. Another feedback loop.
Okay. Coral reefs were mentioned too. How do they fit in?
Coral reefs are incredibly sensitive to temperature changes. Even small increases in ocean temperature cause them stress, leading to coral bleaching where they expel the algae living in them and turn white.
And if the heat persists?
They die. Now, coral reefs are living structures, full of organic matter. When they die and start to decompose, that organic matter breaks down.
Releasing CO2 and methane.
You got it. So warmer oceans kill coral. The dead coral releases greenhouse gases, which contributes to further warming of the oceans, killing more coral. It's a grim cycle for these vital ecosystems.
And the last ocean one, methane hydrates. Sounds ominous.
It does, yeah. Methane hydrates are these weird ice-like structures found on cold, deep ocean floors and sometimes in permafrost. They trap huge amounts of methane gas within a cage of frozen water molecule.
Stable under specific conditions.
Right. High pressure and low temperature keep them stable. But as the deep oceans warm, even slowly, these hydrates can start to destabilize, to basically melt or dissolve.
Releasing the trapped methane.
Potentially vast quantities of methane gas bubbling up from the seabed into the ocean and maybe into the atmosphere. Given methane's potency, a large-scale release is a major concern for rapid, abrupt climate change.
Okay. Oceans covered. Then he moved to land and forests. Soil carbon release.
Yeah, similar principle to permafrost and peatlands, but for soils globally. Soils store enormous amounts of carbon and organic matter.
And warmer temperatures affect this.
They do. Warmer soil temperatures speed up the metabolic rate of microbes in the soil, making them decompose that organic matter faster.
Releasing more CO2.
Exactly. Warmer soils breathe out more CO2, adding to atmospheric concentrations, contributing to more warming, which warms the soils further. Another feedback.
And finally, forests potentially flipping from sinks to sources. That sounds bad.
It's really bad. Healthy forests are crucial carbon sinks. They absorb CO2 as they grow. That's their vital role.
But that can change.
Yes. Climate change brings multiple threats to forests. Increased heat and drought stress trees, making them vulnerable to pests, diseases, and dieback.
And extreme weather.
Stronger storms knock down more trees. Hotter or drier conditions lead to more frequent and intense wildfires.
All releasing carbon.
Right. When trees die and decompose or burn, the carbon they stored goes back into the atmosphere as CO2.
So instead of absorbing CO2, they release it.
Precisely.
Yeah.
And the speaker highlights a critical, alarming finding. Large parts of major tropical forests, the Amazon, the Congo Basin, Southeast Asia, are already thought to have become net carbon sources. They're releasing more carbon than they absorb.
They've already flipped.
In some key areas, yes. That's a huge shift in the planet's carbon balance.
Wow. Okay, so this whole picture.
Yeah.
The unmet targets, the rising emissions, these accelerating feedback loops. It paints a bleak picture for current efforts.
It really does. And this underpins the speaker's deep skepticism. He comes back to that idea of dishonesty and hypocrisy over the last decade.
The analogy he used.
Yeah, the travel analogy. Needing to go 3 kilometers in 3 days, but only managing 50 meters in the first 2, it makes the final goal seem utterly impossible based on past performance.
And he blames political inaction.
A huge part of it, yes. He stresses the lack of honest communication from leaders to their people about how severe this actually is.
Pointing fingers.
He gives examples, like the U.S. temporarily leaving the Paris Agreement. He also talks about the rise of political movements, often on the right globally, that actively deny or downplay climate change.
And notes that they often gain support for doing so.
Which is the really worrying part, right? That downplaying the crisis can be politically advantageous. It creates a huge barrier to the kind of urgent action needed.
So if political action is failing, what does he see as the root cause, the underlying drivers?
He draws a direct line. He points to graphs showing trends since about 1750, the start of the Industrial Revolution.
What trends?
Human population growth, atmospheric CO2 levels, global GDP growth, industrial production, and global temperature rise. He says these curves all track each other remarkably closely.
Implying they're all connected.
His argument is that the fundamental issues are, quite simply, a rapidly increasing human population, combined with ever-increasing levels of consumption per person. More people wanting more stuff.
That's the engine driving it all, in his view.
Yes. He sees these desires as deeply interconnected and as the primary drivers pushing us towards environmental breakdown.
Okay, so if that's the diagnosis, what about solutions? He mentions individual action, his own organization.
He does. Based on his analysis, he argues the only real solutions left involve somehow reducing both population and consumption levels.
Which he admits is incredibly difficult.
Hugely difficult on a global scale, yes. He then talks about the work of his own organization, suggesting it offers a path.
How so?
He claims that individuals who genuinely connect with their teachings, he implies a deeper, perhaps spiritual understanding, significantly reduce their personal environmental impact. He even quantifies it.
What figure did he give?
He mentions a 70–80% reduction in per capita emissions and harmful activities for those deeply involved.
That's a massive reduction.
It is. But he immediately follows that with a sense of frustration.
About the scale.
Exactly. He feels their impact is limited because not enough people are engaging or engaging deeply enough. He even shares an anecdote.
About recruitment.
Yeah, about some members being more focused on bringing in new people rather than fully grasping the gravity of the climate situation themselves.
So superficial engagement isn't enough.
No. He stresses the need for a much deeper understanding. He mentions the Gita, the Hindu scripture, as a potential source of this understanding to motivate real, lasting change in behavior.
So he sees his work as vital, but
constrained. He essentially says they're doing the most important work in the world, tackling the root causes, but their impact is too small because not enough people are truly connecting with it.
Okay, so let's try and wrap this up. The core message from this source, 2025 is this critical point, maybe a point of no return.
Right, because the climate crisis is accelerating fast, these feedback loops are kicking in, becoming potentially irreversible.
And this is happening against a backdrop of failed promises, inadequate targets, rising emissions, and a lack of honest political leadership.
Exactly. The data points are alarming, already hitting that 1.5-degree rise temporarily. The tiny potential reduction from current promises, the massive carbon stores in permafrost and peatlands starting to unlock, it all paints a picture of extreme urgency.
It's definitely heavy information. It can feel overwhelming for sure. But understanding these dynamics, these underlying drivers and feedbacks seems absolutely crucial if we're to grasp the challenge.
It really leaves you thinking, doesn't it? If these natural feedback loops are really starting to take the wheel, as the source suggests, what does that mean for us, individually and collectively? What does responsibility even look like in that context?
Yeah. How do you live consciously? How do you make choices acknowledging these huge interconnected planetary systems, especially when the big political and economic levers seem stuck?
That's the question to ponder, I think. What does meaningful action look like now?